In this tutorial, we will show you how to draw a tangent line on a graph of kinetic data and then determine the slope of that line to calculate the instantaneous rate of the reaction. Let's look at a graph of the concentration of X versus time for the reaction of 2X mixed Y plus Z. We're showing a graph where the experimental data points are plotted as blue circles and they're connected with a smooth blue line to show the best estimate of the concentration at any time. Notice how the concentration of X decreases with time, but not in a linear fashion. In other words, the reaction starts off faster when there's more X around, but then slows down as the reactant X gets consumed. Now let's say we want to know the instantaneous rate of the reaction at 12 seconds. To determine this, we want to draw the tangent line to the data at t equals 12 seconds. So we find the point on the line where t equals 12 seconds. We then add a tangent line at this point. If you're doing this by hand, you would use a ruler. Otherwise, you can use the shapes function in Excel to add a line. We're showing the tangent line in red here. You want to draw the tangent line so that it touches the blue data line at the point of interest, 12 seconds in this case, but does not touch or cross the blue data line anywhere else. Rotate your ruler or line until this is the case. The black line, for example, would not be a good tangent line at 12 seconds because it crosses the data line. If we want to know the rate of the reaction at time equals 12 seconds, we have to determine the slope of the 12-second tangent line, the red line. Recall that the slope is the change in y over the change in x, so we need to find 2 points on the red line. You can choose any 2 points on the red line. I'll choose the green point here as my first point. We draw lines over to the axes to find the x and y values of this point. In this case, we have y is equal to 0.053 molar and x is 8 seconds. My second point is the orange one. Using the same procedure, we find that the y value is 0.030 molar and the x value is 15 seconds. By plugging these values into my slope equation, I find that the slope of the red line is negative 0.0033 molar per second. We're not quite done because we actually wanted the normalized rate of the reaction at time equals 12 seconds. Since X is a reactant and has a coefficient of 2 in the balanced chemical equation, we need to multiply the slope by negative 1/2 to get the rate. Doing this gives an instantaneous rate of 0.0017 molar per second at t equals 12 seconds. Notice that if we draw a tangent line at a later time in the reaction, say at 30 seconds, the tangent has a much shallower slope, which would yield a slower rate. On the other hand, if we draw the tangent line at 5 seconds, we get a much steeper tangent line indicating a faster rate. In this tutorial, we've shown how to take kinetic data in the form of a graph of concentration versus time and determine the instantaneous rate of the reaction at any given time by drawing the tangent line, finding the slope of the tangent, and then adjusting the slope according to the coefficient in the balanced chemical equation.